Chapter 14, Integral Calculus 1, Question 2, finding the original function f. So for part A, we are given the second derivative of f, which is 4x minus 15x squared. So we'll have to take the integral of it 2 times. So first we have the integral of 4x minus 15x squared dx, which we just use reverse power rule. So we add 1 to the exponent, divide by the new exponent, minus 15x, and then 2 plus 1 is 3, over 3. Can't forget plus c, which simplifies to 2x squared, minus 5x cubed. Now we have to take the integral again. So you have the integral of 2x squared, minus 5x cubed, dx, which gives us, and we can't forget plus c. So let me just edit this. This has plus c dx. So we have 2 times x. 2 plus 1 is 3, over 3, minus 5x. 3 plus 1 is 4, over 4. Then we have plus cx. And then a new plus c, which we'll use k as the variable. So that would be the answer for part A. Now moving on to part B, we're given the second derivative, which is 1 plus 3x squared minus 4x cubed. And we are also given that the f prime of 0 equals 2 and that f of 1 equals 2. So that means we'll have to find the constants. So first, similar to last time, we'll have to find the integral. So we have the integral of 1 plus 3x squared minus 4x cubed. Minus 4x cubed dx. So using reverse power rule, that gives us x plus, and then 3x cubed over 3, which is just x cubed. And similarly with this, it's 4x to the 4th over 4. So it's just x to the 4th. We have to put plus c. And now we're given that f prime of 0 equals 2. So that would mean that plugging 0 into all these x's, which would give us just plus c equals 2. So that tells us that c equals 2. So now we'll have to take the integral again of x plus x cubed minus x to the 4th, and then plus c, which we said is 2, dx, which this gives us x squared over 2 plus x to the 4th over 4 minus x to the 5th over 5, and then plus 2x. And then we have another plus c variable, which again we'll use k. Now we know that f of 1 equals 2. So plugging 1 into this gives us 1/2 plus 1/4 minus 1/5 plus 2 plus k equals 2. So making these into the same common denominator, we'll make this 10/20th plus 5/20th minus 4/20th plus 40/20th plus k equals 2. So that gives us 11/20th plus 40. So 51/20th plus k, and then 2 times, it would be a 40/20th. So that means that k equals minus 11 over 20. So that tells us that the answer is x squared over 2 plus x to the 4th over 4 minus x to the 5th over 5 plus 2x, and then we have k is negative 11/20. Moving on to part C, this is supposed to be t. We have f double prime of t equals 8t minus sine of t. So we have to do the integral 2 times again. So first we have the integral of 8t minus sine of t dt. Reverse power rule for the first term gives us 8t squared over 2. And then for the next term, cosine equals negative sine. So that means we just have plus cosine of t. And then we have plus c. We'll have to do it, the integral one more time. So we have the integral of simplified to 4t squared plus cosine of t plus c dt equals 4t cubed over 3. And then sine is derivative of sine is cosine. So the antiderivative of cosine is sine. And then we have plus cx plus k. But this needs to be c plus t, or c times t. Now moving on to part D, we have f prime equals 12x cubed minus 8x plus 7, where f of 0 is 3. So we only have to do the integral one time. So the integral of 12x cubed minus 8x plus 7 dx. Using reverse power rule, that's 12x fourth over 4 minus 8x squared over 2 plus 7x plus c. And now we're given that f of 0 is 3. Therefore, c equals 3. So that means our answer is simplified to 3x to the fourth minus 4x squared plus 7x plus 3. Moving on to part E, we have f prime of theta equals 2 cosine of theta minus sine of 2 theta. So we'll have to find the integral only one time. So I have the integral of 2 cosine of theta minus sine of 2 theta d theta. So for the integral of 2 cosine of theta is 2 times, and then the derivative of sine is cosine. So we just have 2 times sine of theta. And then for this, we'll have to put 1/2. Since the derivative of, and we'll have to do positive. So the derivative of positive cosine, the derivative of positive cosine is negative sine. So the derivative of positive cosine of 2 theta would be negative sine of 2 theta, which is what we have. But then because of chain rule, it would be twice that. So we have to put that 1/2 there. And then, of course, we have plus c.